Hello, Assalamualaikum. Now our project is about the development of a decision support system or DSS for car evaluation using the G48 decision tree algorithm. Using a suitable car can be difficult because users need to consider several factors such as buy price, maintenance cost, passenger capacity, luggage boot size and safety level. Therefore, we develop a DSS that can classify physical acceptability and help users make better and more informed purchasing decisions. The system was built using the car evaluate data set and implement using the J48 algorithm and Now I want to introduce my group teams. First is me, Adam Afiq. Second, Fatih Nurul Najia. Third is Madriatul Shamira. Four is Nurul Balkis Nadira. Five is Nurul Husna, and the last one is Muhammad Nur Iman.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Iman bin Nur Azizi. My number matrix is CI250052. So I want to talk about the introduction of this project, which is our project is building a helpful computer system to evaluate the cars. So we live in a world that technology makes it easier to make the big choices, which is a great tool for the decision support system and investors of the guests. So the system is look for the data and to help the people make smart and also the consistent choice. When they have many the options, so the car is perfect for choice because you have to think about the detail of us and like the buying price, repair cost, passenger size, trunk and also the safety. Because every car have a different, so trying to pick the right one can be very confusing and stressful without a clear guide. So to solve this, our team built a system specifically to help the buyers evaluate the cars. So we took the real car data from the database that we call the kill repository, and then we use a smart computer method that we call the J48 decision tree. So the inside told the name of the car to sort the cars and also figure out the choices to buy. So using the method, we create the simple and also the prototype system can make easy to for everyone and also which is to fit their needs for best. So the next part, which is a project objective. So the main of the goal of the project is very simple. First, we wanted to build a working for the decision support system, specifically for evaluating the cars. Second, we aim to use the J48 decision method to accurate the score and also the group based on the how acceptable that are to buy. And last, our biggest goal is to use the system to help everyday people make faster, smarter and much easier decision, and that's already to buy a new vehicle.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Balkis Nadira binti Samsuri and my metric number is CI250004. Now, I will explain about the problem statement of this project. Choosing the right car can be difficult because there are many factors that need to be considered, such as buying prices, the maintenance cost, the passenger capacity, the luggage boot size, and the safety levels. Many consumers make decisions based on their personal opinions or limited information, which may lead to selecting a vehicle that does not match their needs. In addition, comparing different vehicles manually can take a lot of time and may not always produce the accurate result. And therefore, this project purpose a decision support system that use the J48 decision tree algorithm to evaluate vehicles and help users to make a better and more informed purchasing decision. Next, I will explain the scope of this study. This project focused on developing a decision support system for a car evaluation. The study used a car evaluation dataset from the Kill repository, which contains 1,728 vehicle records. The system evaluates cars based on their several important attributes, including the buying prices, the maintenance cost, the passenger's capacity, luggage boot size, and the safety levels. The J48 decision tree algorithm is used to clarify the is used to classify the vehicles into a different categories of acceptability. The model is developed and tested using a Weka software, and its performance is evaluated using the 10-fold cross-validation methods. And the final output is a prototype system that can assist users in choosing suitable vehicles based on their criteria provided. That's all from me. Thank you.
Hello, my name is Rafi. Now I will explain the methodology used in this project. This project used the Siemens decision-making model, which consists of 4 phases: intelligence, design, choice, and implementations. For intelligence phase, we identify the problem of choosing a suitable car based on multiple factors, such as price, maintenance cost, passenger capacity, luggage space, and safety. For design phase, we select the car evaluation dataset from the key repository and use the J48 decision tree algorithm in Weka to analyze the data. For choice phase, we choose the J48 algorithm because it provides good classification performance and easy to understand decision rules. We also use 10-fold cross-validation to evaluate the model. For the last phase is implementation. The dataset was processed in Weka and generate decision rules were used to develop a simple DSS prototype for car evaluations.
My name is Maritu Shamira binti Mustafa. My student number is CI250068. Next, I will explain the system flow of the proposed decision support system for car evaluation. The process starts when the user enters vehicle information such as buying price, maintenance cost, number of doors, passenger capacity, luggage boot size, and safety level. After the information is entered, the system will process the input data based on the decision rules generated from the J48 decision tree model. Next, the system applies the J48 decision tree rules to evaluate the entered vehicle attributes. Based on the analysis, the system generates the vehicle acceptability result. Finally, the recommendation will be displayed to the user to help them make a better vehicle purchasing decision. Once the results is shown, the process ends. Overall, this system flow helps users evaluate vehicles in a more systematic and efficient way. For this slide, I will explain the decision tree analysis generated using the J48 algorithm in Weka. Based on the analysis, the key finding shows that safety is the most important factor because it appears as the root node of the decision tree. This means safety has the biggest influence in determining vehicle acceptability. There are several decision rules generated from the model. For example, Rule 1 states that if the safety level is low, the vehicle will be classified as unacceptable. Rule 2 shows that if the safety level is high, the passenger capacity is more than 4 people, and the buying price is low, the result will be classified as very good. Meanwhile, Rule 3 explains that if the safety level is high, passenger capacity is 4, and the buying price is low, the vehicle will be classified as acceptable. In conclusion, the decision tree helps simplify the vehicle evaluation process by transforming data into clear and understandable decision rules.
Assalamualaikum, Dr. Malina. My name is Fatinur Najiha, and I will be presenting the results and performance of our decision support system for car evaluation. To evaluate the performance of our system, we use the J48 decision tree algorithm in Weka and apply a 10-fold cross-validation method. This method is commonly used to test how well a model performs because it evaluates the model using different portions of the dataset and helps reduce bias in the results. Based on our analysis, The model successfully classified 1596 out of 1728 vehicle records correctly, while only 132 records were classified incorrectly. This indicates that the model was able to make accurate predictions for most of the vehicles in the dataset. The most important result is the classification accuracy, which achieved 92.36%. This means that the model was able to predict vehicle acceptability correctly more than 92% of the time. Generally, an accuracy above 90% is considered good because it shows that the model performs well and can make reliable prediction even on unseen data. Besides that, the kappas statistic value is 0.8343. This value measures the agreement between the actual and predicted classification. Since the value is close to 1, it indicates a strong level of agreement and shows that the model is reliable. We also obtain a mean absolute error of 0.0421 and a root mean square error of 0.1718. These values are relatively low, which means that the prediction errors produced by the model are very minimal and the classification results are consistent. Overall, the results demonstrate that the J48 decision tree algorithm is effective in evaluating vehicle acceptability. With an accuracy of 92.36%, the model provides strong performance and serves as a reliable decision-making engine for our decision support system. Thank you. After evaluating the performance of the model, I will now explain how these decision rules were implemented in our prototype system. This slide shows the prototype system that we developed based on the decision rules generated from the J48 decision tree. The main purpose of this prototype is to help users evaluate whether a vehicle is acceptable based on several criteria. On the left side, we can see the main interface of the system. Users are required to enter vehicle attributes such as buying price, maintenance cost, numbers of doors, passenger capacity, luggage boot size, and lastly safety level. Once all information has been entered, the user can click the Evaluate Car button. The system will then process the input using the decision rules obtained from the J48 model. On the right side, we can see an example of the output generated by the system. In this case, the result is unacceptable because the selected vehicle characteristic do not meet any the criteria for a recommended vehicle. One of the main advantages of this prototype is that it provides instant recommendation, allowing users to make a decision more quickly and consistently without manually comparing all vehicle attributes. Therefore, this prototype successfully demonstrates how machine learning and decision support system can be combined to assist user in vehicle evaluation. Thank you. I will now pass the presentation to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Husna binti Mat Nasrul. My metric number is CI25006. Today I will continue with conclusion. This project successfully developed a decision support system for a car evaluation using the J48 decision tree algorithm. The system evaluates car based on the factor like price, maintenance cost, passenger capacity, luggage space, and safety. The model achieved 92.36% accuracy, showing that it can classify vehicle acceptability effectively. The result also show that safety is the most important factor in determining whether a car is acceptable. Overall, the system can help user make a car buying decision more easily and more systematically. Next, I will continue with future work. For the future improvement, the J48 algorithm can be compared with other machine learning techniques such as random forest, naive Bayes, and support vector machine (SVM) to identify the most effective classification method. Additional, vehicle-related attribute can also be incorporated to improve classification accuracy and provide more comprehensive evaluation. Furthermore, the user interface can be enhanced to provide a better user experience and make the system easier to use. Lastly, the system can be developed into a web-based or mobile-based application to increase accessibility and allow user to access recommendation anytime and anywhere.